For our questions today, we need to talk about an idea called correlation. Now, correlation is a connection between two variables. For example, typically, if you work more hours, you earn more money at your job. If you exercise more, you burn more calories. If you spend more money, your bank account balance will go down. Those things are all connected with each other. And we can see some scatter plots right here with some points that have a direction or a connection that we can see. These points are going up and to the right. In other words, as this variable increases, so does that one. And as those two increase together, our graph tends to go up and to the right, or down and to the left, which is the opposite direction. This one, on the other hand, as the variable on the x-axis increases, the other variable decreases on the y-axis, and we can see that these are going down. And then on this one, we can't really see a trend. It doesn't look like it's going up or down. This one, there is no correlation. All right, there's some vocabulary words that go along with these. If you see a trend where it goes up and to the right like this, we call this a positive correlation. And the reason for that is because the line of best fit, which you can see right here, has a positive slope. This one, we say, has a negative correlation because the line that fits it is going down and to the right or has a negative slope. And if there is no trend whatsoever, we say that this has no correlation. In other words, there is no connection between the x and the y variables. Now let's take a second and talk about lines of best fit. Lines of best fit are designed to show the direction that the points are going. You notice it doesn't fit exactly all of these points. So with a line of best fit, we try to get the slope to show where the points are headed, and it kind of goes through the middle of all of those points. We're going to create a couple of lines of best fit on Geogebra. If you want to do them by hand, then watch our other video. But let's head over to the computer and take a look at some graphs. Our next task is to take a look at some scatter plots and determine if there is a positive, negative, or no correlation. So you can see that I have taken these values from the table of values and I've put them on the graph right here. And there is a clear trend that the points are going down and to the right. You guys can see that right here. That means that there is a negative correlation for these. Let's take a look at our next one. For these values, we have plotted them again on Geogebra, and I do not see a trend going up or down. This one is an example of a scatter plot that has no correlation. All right, let's take a look at a couple of examples from some data. First, we're going to take a look at this scatter plot right here. And our task is to determine what is the winning percentage of the pitcher who has an earned run average of 4.2. Now we can see that this data is going down and to the right, so it has a negative correlation. As our earned run average goes up, the winning percentage goes down. That makes sense because as the opposing team earns more runs, then your chances of winning go down because they've scored more. So we're going to take a look at each of these and see what we can find from the data. What is the winning percentage of the pitcher who had an earned run average of 4.2? So here's 4. 4.2 is just past that. It looks like this point up here had an earned run average of 4.2. Let's go and take a look at the winning percentage over here. So that looks like the winning percentage is about 600 or 60%. Let's take a look at our next one. We're trying to find the earned run average of the pitcher with a winning percentage of 0.33. So here is 0.3. 0.33 would be just above that, so it looks like we're looking at this point right here. The winning percentage or the earned run average of that player was 5. Let's take a look at our very last one here. What tends to happen to the winning percentage as the earned run average increases? So we talked about that. As the earned run average increases, the winning percentage goes down, and that's because the opposing team scores more points and you don't win as often. All right, we're going to take a look at our last one. This table shows the earnings of a food server who worked for a certain number of hours. So X is our hours, and Y is our earnings. And so we can see that this one has a positive correlation if we graph it. So we're going up and to the right. As we work more hours, we earn more money. We're going up and to the right. Our task is to write an equation that models this relationship. In other words, we are to draw the line of best fit. So we're going to do that by having Geogebra execute a command. This one is called fit line, and it draws a line of best fit. So down here in the input box, I'm going to type equals fit line, and then I'm going to list my points, which are A through G. So A, comma, B, C, D, E, F, G. And you can see that it's drawn a line that goes up and to the right with a positive slope as we expected. And down here in the input box, we have our equation. All right, there's lots of decimal places, so we can just round this to 18.2x plus 1.8. Next, we are to interpret the slope and the y-intercept of the line of best fit. So our slope is rise over run. That means it's 18.2 over 1. So every time we go over 1, which means we worked one more hour, we go up by 18.2, which means we earn $18.20 more cents. That's our rise over run, and our slope tells us how much we earn each hour. The y-intercept of 1.8 tells us how much we would earn with 0 hours of work. That would be 1.7 or $1.70 for working 0 hours in this case. Each line of best fit will have an interpretation, so pay attention to the slope, pay attention to the y-intercepts, and you can get some information from those. Thank you.